Dear students, in this video we will discuss about the covalent bonding. Covalent bonding, in covalent bonding, the stable electronic configuration is reached by the sharing of electrons. So here the atom which tries to bond covalently. So each atom in the covalent bonding will contribute at least one electron and or will share the one electron to bond in this way. So here we take an example of the hydrogen atom. In hydrogen atom, we know that hydrogen atom have only one electron in its 1s orbitals. So hydrogen atom need one more electron to complete its shell. So when two hydrogen atoms come close together, when two hydrogen atoms come close together, we have the situation like this. That is, both hydrogen atoms will share its valence electron. That is, now the valence electron of both hydrogen atoms belong to both the atoms. That is, they are shared among both the atoms. So we can say that the covalent bond is directional in nature. That is, it is between the specific atom. It is only in the direction between one atom and the other atom that participate in process of sharing of electron. So the covalent bond, number of covalent bond that is possible for the particular atoms can be determined by its valence electron. For example, the hydrogen has one valence electron and it needs one more valence electron to complete its shell. So like we have another examples. Here we have an example of the diamond, which is very rigid and hard covalently bonded structures. As we know that diamond is composed of the carbons, as the carbon atom which needs the four more electrons to complete its shells. So it means that it can make the four covalent bond. So every carbon atom, like this one carbon atom, it is covalently bonded to this carbon atom, and it also shares its electron with this one, and with this one. So it means that every carbon atom within the diamond structure making the covalent bond with four other carbon atoms. So it means that there is the extensive type of the covalent bonding within the diamond. So due to this much extensive and rigid type of the covalently bonded structure, rigid covalent bonding, extensive covalent bonding, the diamond is a very rigid material, and as a consequence of this type of the bonding, it has very high melting point. That is more than 3500. That is I think it's 3550 degrees centigrade. That is, it has so much high melting point due to this extensive type of the covalent bonding which is found within the diamond structure. Let's take another example of covalently bonded compound like methane, which is composed of carbon and hydrogen. As these are the two dissimilar atoms, as we know that the carbon atom which need the four electrons to complete its octet, so it can make the four covalent bonds. So here this one is the carbon atom. So carbon atom share its four valence electron to four other hydrogen atom. As we know that in the case of hydrogen atom need only one electron to complete its shell, to complete it 1s orbital. So there are the four hydrogen atoms which will share the four valence electron of the carbon atom and makes the molecule of methane. Here we can see in this structure that this one is the carbon central atom, and carbon atom sharing one electron with this hydrogen atom, sharing one electron with this one, with this one, with this one, and thus making the molecule of methane. This is an example of the covalent bonding between two dissimilar atoms. Let's have a look another type of the covalently bonded compound, that is propane C3H8. This is the long chain hydrocarbon, that is it contains the carbon and hydrogen. All hydrocarbon contains the carbon atom and hydrogen atom. So in hydrocarbons we can see that here this is the structure of the propane. This one is the carbon, this one is the carbon, and this one is the carbon, and these are the hydrogen atoms. Here we can see in this structure that this one carbon atom is there, as the carbon atom has the 4 valence electrons, so it's sharing one electron with this hydrogen atom, one electron with this one hydrogen atom, and this one hydrogen atom, and the remaining one electron is shared with the neighboring carbon atom through covalent bonding. And similarly, this as we see that this central carbon atom sharing one electron with this one carbon and one electron this carbon through covalent bonding, and remaining two electrons are covalently bonded through single covalent bond with this hydrogen atom and one with this one hydrogen atom. And similarly, this last carbon atom also making the 4 covalent bond, one with the carbon atom and 3 with the other hydrogen atom. This one is about the structure of propane. Similarly, all other long chain molecules, long chain hydrocarbons, fluorocarbons, like all polymeric materials, have the covalent bonding. We can observe the covalent bonding in all long chain molecules. And this one is the schematic diagrams of the covalent bonding within the structure of the propane. So thanks for watching, and in our next video we will discuss about the different types of the covalent bonding.